All right, welcome back. We're in Khan Academy under Algebra 1, and the unit is quadratic functions and equations. This skill is quadratic word problems in standard form, so they give us some quadratic function in standard form, and they give us some context for what these things mean, and then they ask us a question. Okay, here's the context. Well, actually, it's a good idea to look at the question first and then go back and try to interpret the context with the question in mind. So, the question is, what is the maximum power generated by the circuit? Okay? The power generated by an electric circuit in watts as a function of its current, C, is modeled by this equation. So, power, P, is a function of current, C. So power in terms of current equals whatever this evaluates to given your particular current, C. All right? They want to know what the maximum power generated by the circuit is. Okay, this is a quadratic function, and so we look at the coefficient on the x squared term, in this case the c squared term, and it is negative, which tells us that this parabola opens down, so it looks like this. They want to know what the maximum power generated by this function is. So this parabola models the power, that is the y value is the power. The maximum y value would be up here at the vertex. So they're asking us what the power is. That's the y value. So their question boils down to what is the y coordinate of the vertex of this parabola. Okay, so in order to know what the y value is, we can figure that out if we know what the x coordinate is. And we know from the quadratic function that the x coordinate is always equal to negative b over 2a, where a is negative 12 in this case, b is 120, and so we can solve, and that will be negative 120 divided by 2 times negative 12 is negative 24. Negatives cancel, so we get 120 divided by 24, those are both divisible by 12, so 10 divided by 2, and that simplifies to 5. So our vertex, right there, has an x coordinate of 5. That is, when c equals 5, we are at the maximum point on this parabola. So now we just have to evaluate the function at c equals 5. If c is 5, we get negative 12 times 25, 5 times 5, plus 120 times 5. So there are 4 25s in every 100, so we have negative 300 plus 5 times 120 is 600. So the maximum watts are 300. That's what we'll put in to answer this question. 300 watts. Next question. All right. Elaine throws a stone off a bridge into a river. Okay, the height above the water is what the function models, and the input is seconds, x, after throwing it. So, question is, how many seconds after being thrown will the stone hit the water? Okay, so in this case, again, the parabola opens down. We know that because the coefficient on the x squared term is negative. So she throws it, and it goes down here, and it hits the water. Here's our water, right over there. She was on a bridge when she started, so we know Here's our bridge right here. She's above the water on this bridge. She throws the stone, and some number of seconds later it hits. How many seconds after does it hit the water? They're looking for the y, not the y coordinate, the x coordinate. They want to know seconds. So we're looking for the x coordinate of that point where it hits the water, and the water is where the height above the bridge is 0. So we want to say that the height is 0, and we want to know, where does this happen? Where is this function equal to 0? It will have, theoretically, an x coordinate over here that would be negative, but we're not interested in that one, so we're going to be interested in the positive solution to this equation. All right, so if we divide both sides of the equation by -5, we get x squared minus 2x minus 3, and we can solve this equation. We can factor it, so let's say 0 equals x times something, x plus something times x plus something. Let's see if we can factor this. If we can, it'll make it an easy problem. So let's see. We need a product that's 3, so that'll be a 3 and a 1. We actually need it to be negative, so one of these two has to be negative, the other positive, and when we add them together we get a -2, so the larger has to be negative. X times x is x squared, -3x plus another x is -2x, and -3 times 1 is -3. So, in order to make this equation true, x could be 3 here. So if x equals 3, then y equals 0. Or, over here, it'd be x equals -1. So theoretically, if that path had been taken in a negative second, it would have hit the water behind you. Of course, negative seconds don't exist, but here we go. Positive 3 seconds, 3 seconds after she launches this thing, it hits the water. That's our answer. Next question. A hovercraft takes off from a platform. I'm looking at this. Function is going to give us information about that. I see that it's a parabola that opens down, so I'll just draw that. Started on a platform. Something's falling. We're going to hit a ground sometime here. So the how many seconds after takeoff will the hovercraft reach its maximum height? So what point on the parabola is the maximum height? It'll be the vertex. That's as high as it gets, right here. So in order to find the vertex of a parabola, using part of the quadratic formula, we can say that seconds is x, so we're only interested in the x coordinate, which is -b over 2a. -b is -20 over 2 times -2 is -4. That equals 5. So the vertex happens at 5, h of 5, but we don't really care how high it is off the ground. How many seconds after takeoff will the hovercraft reach its maximum height? We know now that it's 5 seconds. And we'll be done.